Hey y'all, we are Memphis Community University and we're back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today we're going to be starting our differential equation unit, primarily focusing on differential equations that appear on the AP exam. And we're going to start off with the big one, folks. Today we're going to be starting off with separated integrate. So on differential free response questions, differential equation free response questions, these separated integrate questions could be as many as 5 to 6 points out of 9. So they are the biggie sort of questions. And what we're going to see is that it's just going to be a very involved process, but it's not going to be too bad. It's going to be called separated integrate because you're going to separate an equation into two variables and then you're going to integrate both sides. There's going to be two main cases. We're going to talk about the non-ln of y case. Basically, if you don't have an ln of y, that case is pretty easy. Then we're going to talk about an ln of y case where we're going to skip a few algebra steps, but once you skip those algebra steps, it's not that bad of a question. But we do want to start off with steps, so let me start off with steps. Again, this is separate and integrate, the most important part of differential equation free response questions by far. This lesson alone is more important than all the other differential equation lessons combined. So let's get started. Let's go over some steps. So again, we're doing separate and integrate. Separate and integrate. So on the AP exam, you're going to have some pretty easy differential equations. Remember that differential equations are equations that involve a derivative, of course, where the answer will be a function, as opposed to our normal algebra equations where the answer is usually a number. So your answer is going to be something like y is equal to x squared plus 3, something like that. And remember that there are two cases, so we're going to talk about two cases. The first case, we're going to start off, the first half of the video will be on the non-ln of y case, so no ln of y. So what you do in this case is you first separate, and we're going to give tips on how to do each of these steps throughout the video, but you separate into two variables. Usually this is through cross multiplying and cross dividing. The second thing you're going to do is you're going to integrate both sides separately. So we're going to integrate both sides. Keep in mind that we might have to use sub if necessary. The third step is going to be, once you integrate both sides, remember the plus c on the x side. You don't have to have two plus c's because you can combine the plus c's into one plus c. I always keep it on my x side or my t side, whatever the independent variable is. Finally, what you're going to do is you're going to use the initial point. So there's always going to be two givens, the differential equation and the initial point, and you're going to use that initial point to find the plus c. So use initial point. Let me see if we can write this. Use initial point to find plus c. Finally, what you're going to do is you're going to solve for y. Just a quick little algebra step where you're going to isolate y. So isolate y, and that'll be your answer. So again, as we talk about this, we'll talk about some tips and warnings for each of these steps. Step 3 is super important. Just writing plus C gives you a point maybe on the AP exam if you just remember plus C, and not writing plus C maybe takes away 3 points. So step 3 is the easiest step, but it's also the step we want to be aware of. So what about the ln of y case? So the ln of y case, it's not the harder case, it's maybe the more weird case. So in the ln of y case, what's going to happen is that on the y side, you're going to have ln of y somewhere. So what are the steps for this one? Well, the first 3 steps are the same. 1 through 3, the steps are the same as this side right here. We're going to separate by cross multiplying. We're going to integrate by both sides, potentially u subbing, and then we're going to have a plus c on the x side. So the step 4 would be to isolate the ln, because you're going to have, this is the ln case. And again, maybe none of this makes sense, but hopefully you'll write down the steps, and then as we practice these examples, these steps will make sense. So what we're going to do is we're going to isolate, if I can spell isolate right, isolate the ln, might be some function g of y, so that we have the form ln of g of y equals f of x plus c. So this is what it's going to always look like. And then what we're going to do is that because we have this ln of y, it's really difficult to find the plus c because it involves exponential and logarithms. But what you can do is you can sort of get rid of all this stuff and you can convert this function into an easier form. In our first example of an ln of y case, I'm going to do all the steps. But when I tell my students how to do this process, I skip all the steps you'll see which ones I skipped, where I'm just going to go straight to this formula. Y equals, and the point is to change the plus c into a times a, changing the constant of integration to an easier constant of integration to solve. So it's going to be g of y, whatever is in the parentheses, g of y is equal to a e to the f of x plus c. The plus c becomes an a, so you're going to be left with just this formula right here. And this formula is going to be very easy to solve things. Keep in mind that we basically changed the ln to an e, so that we got rid of the ln because ln's are a little bit tricky. Finally, what you're going to do is you're going to use the initial point again, not to find plus c, but to find a instead. So use initial point to find a instead. And finally, just like in the non-ln of y case, the last step is to find y. So again, the key step in the ln of y case is once you get this ln of something with y equals something with x's plus c, we're going to do this conversion step where we're going to have g of y equals a e to whatever that function is. You'll see why this is true, but again, you don't really need to know it if you just keep doing these questions over and over and over again. So please write down these steps. I want to start with examples because these questions are so important. Again, as we talk about the examples, I'm going to refer to these steps, so hopefully you have these written down and we can just start. So I'll give you a second, pause the video, 3, 2, 1, let's go for examples. So again, what I plan to do is I plan to do maybe 3 non-ln y case examples, and then I'm going to do 3 ln of y cases examples. So let me erase this. So our first example. So again, what the givens in these questions will be something like dy dx equals some function y squared, and we'll have something pretty easy at the beginning. Let's just put x here, and then you're always going to be given an initial condition. So I believe that I want my initial condition to be something like 0, 2. So we're going to start off with this question right here. So again, this is the non-ln of y case, as you'll see, but let's just get started. So the first step, and the most important step, and potentially the easiest step, is to separate everything. So basically what we're going to do is we're always going to bring the x's to the right side, and we're always going to bring the y's to the right side. So for example, I need to bring this y squared over, so I'm going to multiply. So it looks like I got y squared times dy. Then I'm going to bring my dx over to the other side, so it looks like I'm going to get x times dx. So again, that was my separate step. Bring all the x's to one side, bring all the y's to one side. Be careful differentiating between dividing and multiplying. Sorry, I got confused there. So for example, in this case, we multiply everything, but potentially you might divide by things, as we'll see, especially in that ln of y case. Just be careful. I need to bring the x's to this side. I need to bring the y's to this side. How am I going to do that? Multiply or divide. You usually don't use subtraction or addition. So then, once you have everything isolated, notice that on this side, there's only y's. On this side, there's only x's. This is the second step of separate and integrate. We just separated, now we're going to integrate. So we're going to integrate this. Looks like these integrals are pretty easy. This is just the power rule. It's going to be y cubed over 3. And then this integral is going to be x squared over 2. Add 1 to the exponent, divide by your exponent. So it's going to be x1. So 1 plus 1 is 2. Divide by your new exponent, divided by 2. And of course, the most important thing by far is to remember plus c. That plus c is the key part of this, the easiest part and the key part of this sort of process. And remember that I like to have only 1 plus c because if you have 2 plus c's, you can combine them into 1 plus c. I always have my plus c on the x side. So notice that on this left side, after we separated and integrated, we have y cubed. Let me retrace over this y cubed. Maybe I failed there. We have y cubed over 3, and notice that it doesn't have ln of y. So this is what I call the non-ln of y case. We don't have an ln of y. So what you do is you're going to immediately plug in this point. We're going to plug in 2 here, and we're going to solve for c. So it looks like we have some fractions here, but it can be 2 cubed over 3 equals x. And then we have 2 points, and we have 2 variables, so you're going to plug in each point into the correct variable. So this is going to be your x, 0, and then this is going to be your y, 2. So it's going to be 0 squared over 2. So you have a bunch of variables, but you're going to plug in your x and y so that you can find c. In this case, it looks like c is equal to 8/3. Good to go. So then at the very last step, you're going to replace the c with what you found because we are so happy that we found their plus c that we want to replace it. Looks like it's going to be 8/3. And at the final step, maybe an annoying step, but you do need to isolate y at the end. Looks like we can multiply everything by 3, so it's going to be y cubed equals 3x squared over 2 plus 8. And then finally, what we're going to do is we're going to take the cube root of everything, and we're going to be good to go. So we're going to take the cube root of everything, and that's the answer. So again, the steps are you separate by either multiplying or dividing, then you integrate two integrals, one for the x integral, one for the y integral. Remember that plus c on the x side. If you don't have ln of y, then you can immediately go for that plus c. You can plug in your initial condition, x coordinate, y coordinate, right here and here. You'll find a c, then you'll replace your c with what you found, and then finally you're going to isolate y. In this case, it involved multiplying by 3 and taking the cube root. And this is the final answer. Again, the answers to these differential equations, these simple differential equations, are just an equation itself, as opposed to a line, as opposed to a number. I don't know what I'm talking about anymore. But again, separate, integrate, plus c. If you don't have ln of y, go for the plus c by plugging in the point, and then solve for y in the end. So let's practice this again. So I'm going to erase this. Let's erase this. So let's do something a little bit trickier in terms of the integrals. Let's have dy dx. Then let's have, let's say y plus 1 on this side, and also let's have sine of, maybe cosine. Let's do sine. Let's do sine of, what do we want? What do we want? Let's do sine of pi x. And then we're going to have the initial point be 2, comma, 1. 1, comma 2. Sorry, did not really prepare for this, so I'm trying to do this in my head. But here's my next differential equation. So the first step is to separate, and there's some bad things you can do at the beginning that we want to avoid. The first thing is that we shouldn't really distribute this into this. We're going to have y plus 1 squared, by the way. We're not going to distribute this at all, because if you distribute it, you're going to combine a lot of x's and y's, and the point of the first step is to separate everything. So our goal is to separate everything. So that means that usually in our separate and integrate step, what we do is we just either divide or multiply. So let's do that. So it looks like when we divide this over, we want to divide this y plus 1 squared to the other side. And if we get it to the other side, notice that we're not multiplying y plus 1 squared, we're dividing by y plus 1 squared. So it's going to be dy over y plus 1 squared. Then this integral, while we have a dx, we need to bring the dx over. So it's going to be sine of pi x times dx. So this is my separate step. Again, be very careful whether you're multiplying or dividing each of the terms. So when you have isolated this, notice that we did it correctly because we have a nice two guys that are separated. X's are all on one side, Y's are all on one side. So what we're going to do is we're going to integrate. So let's integrate the Y side first. If you want to, you can do our normal integral rules, of course. You can change this to y plus 1 to the negative 2 before you integrate, because I want to do the power rule. Keep in mind that if this was to the 1, it's ln. So that will happen quite frequently. That's the ln of y step. But here we're still doing the non-ln of y step. So in this case, it is not ln. It's only ln when your denominator is to a linear factor. So it'd be y plus 1 by itself. But if you have something like square root of y plus 1, y plus 1 to the cube, or in this case, y plus 1 to the negative 2, in this case, it's not ln. So just keep in mind that not every fraction is ln. It's when it's linear. So then this integral is going to be sine of pi x times dx. So obviously, if you're taking integrals, it's great to be pretty good at integrals. If you want, you can review some of our integral videos, including our AB integral review, where we talk about how to skip easy u subs, because technically both of these are u subs. So let's try to do this integral. Well, the rule will be, because we're doing the power rule and it's not ln, you add 1. So it's y plus 1 to the negative 1, and then you divide by your new exponent, but divided by negative 1 is the same thing as multiplied by negative 1, so we have this. Then we have to do this integral right here. What's the integral of sine? Well, it's minus cosine. Then we have pi x, and then finally we do have to account for that the derivative of the inside function isn't just 1, like the previous one, it's actually pi, because the derivative of pi x is pi. Because we're taking an integral, we're not going to multiply by pi using the chain rule. We're actually going to divide by pi using a u sub. So in this case, the final integral will be negative 1 over pi dx plus c. So again, remember that plus c. But be careful with these integrals. If you need to, you could u sub this on the side, certainly. You could say u is equal to pi x, du is equal to pi dx. You would have the 1 over pi, but it's easy to skip these easy u subs if you see them. So this is my integrate step. Looks like I did it correctly. Integrate, and again, the most important thing potentially is the plus c. So now what we're going to do is we're going to go for the plus c because again, we don't have an ln of y on the left side. So we're going to write this as negative 1 over y plus 1. Usually we change things to negative exponents before we do the power rule, and then we change them back when we need to manipulate sort of algebraic steps. So it's going to be negative 1 over pi cosine of pi x. So this plus c might get a little bit weird, but I'm not scared. Looks like when we plug in, remember that once you have everything ready to go, after you take your integrals, you're just going to plug in your point. We're going to plug in this. Looks like it's negative 1/3 because we're plugging in 2 for y. Then on this side, you're going to get negative 1 over pi, then cosine of pi plus c. Well, cosine of pi is, because we plugged in 1 for x, cosine of pi is negative 1. So this is just going to be 1 over pi plus c, negative 1/3. And then finally, we need to isolate c. C is going to be kind of weird in this case because I just made this question up. But it's negative 1/3 minus 1 over pi. Nothing too crazy. So then what you do is you're just going to solve for y. So let's see where we can write this. Let's write it over here. Negative 1 over y plus 1 equals negative 1 over pi cosine of pi x. And then this weird c of negative 1/3 minus 1 over pi. So we do have to isolate this guy. Looks like there's a lot of negatives, and actually every single term has a negative, so I can erase all the negatives. You can't all things out, so I'm going to erase that. So this will be plus, and this will be plus. Finally, I need to isolate this y plus 1, bringing it to the numerator. So all I'm going to do is I'm going to cross multiply. So I'm going to cross multiply the y plus 1, and I'm going to divide by this entire monstrosity on the bottom. And then finally, to isolate, you would just subtract 1. So the final answer, I believe, is going to be y equals 1 over all of this stuff. 1 over pi cosine of pi x plus 1/3 plus 1 over pi. And you can certainly multiply by pi and 3 to avoid fractions within fractions. But as long as I have a simplified form, y is equal to something, I'm content. And then this was cross multiplying everybody, so this would be y plus 1, and then we're finally bringing the minus 1 over, so this is minus 1, and this is the final answer. So this was a little bit harder of a question, obviously, because it required a little bit more algebra, and the integrals were harder, but it's still the same process. Hopefully you see that. So again, first step is to separate, and separate really slowly, because if you mess up the separate step, unfortunately the rest of the question is wrong. So in this case, we divided by y plus 1 squared, and we multiply by dx. Then you integrate both sides. So in this case, the integral was not ln of y because we were to the 2 and not to the 1. So we did the power rule instead. Y plus 1 to the negative 1, negative. Then on the other side, we had an u sub in our head. So the integral of sine is negative cosine. We didn't change the thing in the parentheses. And finally, we will multiply by 1 over pi. If you need help with especially AB integrals, again, watch our AB integral review. Finally, don't forget to write the plus c, and then use the 1, 2 to find that plus c, and then slowly isolate that y once you have that plus c and replace it with what it is. So that's how you do a non-ln of y example. Let's do one more, and then we'll switch to the ln of y examples, which in my opinion are maybe more fun depending on your definition of fun. So I'm going to erase this. So let's do, the one I want to do, I believe, is divided by y. Let's do secant squared. And then we're going to have the initial condition, which again is a given, so you don't have to find this. It's going to be negative 2. So this is going to be a slightly easier one. So what you want to do right now is just practice the process. So pause the video right now. Do this question for yourself. See if you can do it. Separate, integrate, plus c, solve for the plus c, and then solve for the y. I will let you work. Give me 3 seconds. 3, 2, 1. Hopefully you unpause the video. Hopefully you had a chance to do this. Let's do this together. So again, we're going to separate. Looks like in this case, it's all going to be multiplied because I need to take this y over. I always like my left side to be the y side. So it's going to be y times dy. Then you're going to bring this dx over. So it looks like that's going to be secant squared times dx. So now that I have both of the variables separated from each other because they don't really like each other, we're able to integrate. So we're going to integrate this Nice to memorize my integrals, of course. What's the integral of secant squared? Well, that's just tangent x. Might as well write our plus c because the plus c is the most important part. And then finally, what's the integral of y? Well, that's just y squared over q. Just the power rule, simple power rule, add 1 and flip. So this is going to be your guy right here. So now, looks like we don't have an ln of y. This is the last non-ln of y case. So what we're going to do is we're going to plug in 0 and negative 2. So we're going to get tan of 0, which is 0 from the unit circle because you're dealing with the point 1 comma 0, the y coordinate over the x coordinate, 0 over 1, plus c, so this is 0. And then we're going to plug in negative 2 into here. So it's going to be negative 2 squared over 2. So it looks like our c is actually a lot easier than the last question. Looks like our c will just be, well, negative 2 squared is 4, divided by 2 is 2. So it looks like c is 2. So then remember what you do is immediately once you find c, you don't care about c anymore. Replace the c with what you found because now we know what it is. So it's going to be y squared over 2 equals tangent x plus 2. Finally, we do have to isolate. It looks like we have to do 2 steps. We have to first multiply everything by 2. So I believe that it's going to be this. Be careful that you multiply each term by 2. And then finally, you have to take the square root. Unfortunately, this is not correct because remember if you have something like x squared equals 4, x is not just 2, x is plus or minus 2. So you do have to determine when you take these weird square roots, and this does occur in the non-ln of y case whenever you have a y squared, you have to determine between plus or minus. But it's actually a very easy determination. It's based off the y coordinate of the initial point. So in this case, because the y coordinate is negative, I'm actually going to choose the negative. So it's one small point at the very end that you did have to choose between plus or minus, but that's how it goes. So this was a pretty standard separate and integrate question, probably easier than the last one because the integrals were a little bit easier and the solving was a little bit easier. We still separated, we still integrated, remembered our plus c, we used our initial condition to find our plus c. The only thing that was a little bit tricky at the end is that when we square rooted, we have to remember plus or minus, and in this case it was minus, and then finally we have our answer once we have that. So again, this is the non-ln of y case. When you don't have an ln of y, immediately go for plus c. So now let's do the famous ln of y case, because this does occur maybe 50% of the time. So let me erase this. So the ln of y case. So let's say we have dy dx, like our normal question, equals, let's say we have x cubed times y, and then we're going to have the initial point 0, 2. So this is my next question. This is going to be our first ln of y question, as you see. So the first step, remember that the first few steps actually of the ln of y case is similar to the non-ln of y case, because you're only going to be able to recognize that it's an ln of y case after you take the integral. So what you need to do is you need to separate and integrate and remember that plus c. So in this case, we're going to separate. So it looks like we have to bring the y down because it's on here and we need to bring it to the left side. So it's dy over y with division. Then we bring the dx over, so it's the x cubed times dx. X cubed. These integrals don't look too bad, so I'm just going to integrate them real quick. So these integrals are ln of y. Technically, it's the ln of the absolute value of y. That's the rule in the table. And then finally, this one is the power rule. So it's going to be x to the 4th over 4. Add 1 and divide by your new exponent. And then again, you remember your plus c. So none of this is new from our previous examples. It's still separate. It's still 2 integrals. It's still plus c. But again, it's hard to find the plus c in my opinion, because if you plug in for the c, you're going to get ln of 2, and you might not know how to isolate the integral itself. So what I do is I do a series of steps to change the ln of y into an a. So I'm going to focus on that. So the next few steps you don't actually have to write down because we're going to go straight from this to this. And again, when we started doing the intro, we listed out the steps. There was one step where we went straight to something, and you'll see that step. But I'm going to do the steps for the first one, and again, I'm not going to write these down for the later ones. So it's going to be skipping these steps right here. So the first thing I'm going to do is I'm going to isolate the y. And how do you isolate an ln of y? Well, you raise both sides to the e. So you're going to get e to the ln of y equals e to the x to the 4th over 4 plus c. So just raising both sides to the e. The reason we're doing this is that we can get absolute value of y because e and ln cancel because they're inverse functions. And then remember that when you have e to a sum, that's the same thing as e to the a times e to the b, because we have this formula right here, a nice little standardized test formula from Algebra 2. When we have this, this is equal to this by exponential rules. So we can write this as e to the x over 4 divided by 4, and we're going to write e to the c in the front actually. Then because we have absolute value, we're going to write plus or minus. So y is equal to plus or minus e to the c, e to the x to the 4th over 4. But again, I don't write any of these steps. Basically what we're going to do is that we had this constant of integration that's called c, and we formed it to be plus or minus e to the c, but that's such a complicated constant that we're just going to change it to a big A. So when I do this, I skip to this step right here. A, so plus or minus e to the c just becomes a, e to the x to the 4th over 4. There's no more plus c because the plus c got absorbed into the a as long as the absolute value. So again, when I do this, I'm going to go from here right to here. And that's a pretty easy thing. When you have the ln of y case, what you're going to do is you're going to write whatever was in the ln function. So in this case, it was just y. Then you write a big A, then you write an e, and then you raise it to whatever power it is. And notice that when we have this form, it's going to be pretty easy to find our final answer. Because instead of finding plus c, we're going to solve for this easier constant of integration, which is just a. So when we plug in 0 here and 2, it's going to be 2 equals a e to the 0 over 4. Well, 0 to the 4th is 0, divided by 4 is still 0. So it looks like it's just e to the 0, which is a. So again, it's like the previous examples, but you're not solving for plus c, you're solving for a. Looks like a is just 2. And then we have the nice equation 2e to the x to the 4th over 4. Maybe I can write that a little bit neater. And that's how it works. So again, when you do these questions with the ln of y case, the new step, the big step is going from this, automatically this, and then instead of solving for plus c, you're going to solve for times a. So let's try to do this again, because it is not the easiest thing in the world. So I'm going to erase this. But again, separate, integrate, plus c, change the ln of y plus c into this form right here. So let's see if we can do this again. So I'm going to erase this. Let's change this initial condition. Let's change it to something like 4, 2 or something. And then we're going to have this function where it's going to be y plus 1, and then we're going to have divided by square root of x. So this is my next differential equation. So and whenever you have the differential equation, this is the separate and integrate process where you're solving for variables. Usually they use the word separate and integrate, or separation of variables, or find a particular solution. Usually you have a ton of space on the free response questions because this is such an involved process, but let's get going. So again, like normal, you separate. So it's going to be dy over y plus 1. Looks like we have to divide this y plus 1 to get it to the other side. And then we have square root of x dx over square root of x. Just keeping the square root of x in the denominator and bringing over dx. So now we integrate both sides. So it looks like for this x integral, I'm going to rewrite it as a negative exponent in fractional so that I can do the power rule. So then what's the power rule? Well, you take negative 1/2, you add 1, so it's going to be x to the 1/2. Then you flip your new exponent, so it's going to be times 2. 1/2 flipped is times 2. I'm not going to forget my plus c. Even if we're going to change it to an a eventually, I still like to write the plus c. Then what's the integral of this? Well, this is different than the second question, I believe, because this is not to the second. So this actually is ln. Not every fraction you see is ln, but this one actually is because it's a linear term, y plus 1. So in this case, it's going to be the ln of y plus 1, an absolute value. So again, looks like we have an ln of y case. We have ln of something with y's. So we're going to immediately go to our important step without having to do all those algebraic steps. So again, the way it works is that you're going to have whatever was in the ln. So it's going to be y plus 1. Then you're going to write a nice big A. You're no longer going to write plus c because it became a. And then you're going to write e to the function right here. This is just 2 square root of x. So again, it's a pretty easy process in my opinion, changing this plus c to a, and it's so much easier to solve for the a and also to solve for y in the rest of your questions. But it does require a little bit of know-how, which is you just write the function, you write a nice, beautiful, lovely a, e to whatever this power function was. You don't need to write plus c. Writing plus c is technically wrong because now it's absorbed into an a. And now we're going to use the initial condition, of course, not to solve for your plus c. You can forget about plus c for the rest of the question. Now we only are focusing on this a. So what we're going to do is we're going to plug in. So it looks like we're going to plug in 2 for y, of course, and then we're going to plug in 4 for x. So it's going to be 2 plus 1 equals a e to the 2 times square root of x, which is square root of 4. Square root of 4 is 2, so that's nice. So it looks like a e to the 4th equals 3. So it looks like I have the weird number a is equal to 3 e to the 4th, but I'm not going to complain too much because, again, once I solve, I'm just going to replace it with this. So it looks like we have y plus 1 equals this thing times e to the 2 square root of x. Just like normal, you do have to isolate y, but isolating y is very easy. In this case, we're just going to subtract 1. So it's going to be y equals 3 e to the 4 over e to the 4th. You can combine these into a single e, but I'm not going to do that. E to this 2 square root of x minus 1. So this is the nice answer. Again, it's a function. So even in these weird ln of y cases, if you know this key step, then you're going to be able to solve it, in my opinion, more accurately. So again, you separate, be careful with whether you need to multiply or divide things. Then you integrate both sides, potentially using new subs, potentially not using new subs. And then what you do is you try to isolate as best as possible. Once you get this ln of y case, change it to an a. Whatever is in the ln of y, a nice beautiful a, e to whatever the x function was. Then forget about plus c because the plus c and the absolute value get absorbed into the a, sort of from our first steps. So what you're going to do is you're going to plug in 4 and 2 into this function. And in this case, we got our weird a, but we didn't really care about it because we immediately placed that a with that number, and then we solved. And so that's how it works. Again, it's separate, integrate. If you get ln, change the ln of y stuff with a plus c into a times a, and then you're good to go. So let's do one more of these and call it a day. So I'm going to erase this. I'm going to erase, erase, erase. So let's do something like, I don't know, x squared times 2y plus 1. And we're going to have a nice, easy initial condition. And let's use 0 as the x coordinate to make everything easy. And let's change this to a 5. So this is going to be my question. If you want, last one, pause the video, try it for yourself. There is going to be 1 or 2 steps that are a little bit tricky that I'm going to try to highlight. But try this one for yourself. Hopefully you had enough opportunity. Let's go for it. So again, one of the main things you want to avoid when you separate is try to distribute this, because then you're just making x and y get to know each other very well, and we want them to be very far apart. So I usually never distribute. I only start multiplying or dividing certain terms to get them on other sides. So in this case, we're going to bring the dx over. So it's going to be x squared times dx. And we're going to bring this 2y plus 1 over. So it's going to be dy over 2y plus 1. Then we're going to integrate. Let's integrate this other side because this other side looks easier. Just the power rule, of course, add 1, flip that new exponent, x cubed over 3. Even if this will be an ln case, we're going to write plus c. Then, because this is linear, y is equal to mx plus b, this will be an ln. So it's going to be the ln of 2y plus 1. But what I like to tell my students is that it's not always just ln, especially because we have a derivative of a function who's not just 1. You do have to account for that. That's that skipping that easy use of step. So what we need to do at the very front of this is we need to multiply by 1/2. Because we have to, instead of multiplying by 2, like a chain rule question, taking derivatives, we're multiplying by 1/2 because we're taking antiderivatives. Keep in mind that if you have the general formula of dy over, let's do dx's actually, dx over something, a line, so mx plus b. The general formula, because of a u sub, will be ln of this thing, because it's linear. And then you're going to multiply by the derivative of the inside function's reciprocal. So in this case, what's the derivative of the inside function? Well, it's just the slope of this line, n, and you're going to multiply by 1 over m plus c. Again, if you want to, you can do the u sub. U is equal to mx plus b, du is equal to m times dx, bringing the 1 over m. But I feel like it's easy enough to just skip it. As a nice practice, for example, dy over 7 minus 8y, this integral will be ln of 7 minus 8y plus c, and then you divide by your slope, which in this case is negative 1/8. So that's how you do these questions. So let's go back to the one that we're starting off with. So looks like we have done the meat of the question. We separated everything. We took two integrals where this integral required an easy use of. That's why this 1/2 is done. Keep in mind that you can only e and ln, or you can only ln of b. So before we change this plus c into a lovely a, we do need to bring this 2 over so that it's just ln on one side, so that when we e it, everything goes away. So I tell my students, isolate the ln first. This was in the steps, but we didn't have to do this in the previous two questions because the ln was already isolated. So again, I'm just bringing this 2 over. It's going to be 2x cubed over 3. If you want, you can write plus 2c, but I'm just going to write plus c because, again, it doesn't really matter because we're about to change the constant to an a. So how does this work, of course? Well, you just take whatever's in the ln, 2y plus 1. Then you remember and write a big, lovely a, and then you're just going to have e to this power. 2x cubed over 3. So now it looks like we changed successfully plus c to a. So we're going to forget about plus c. We're going to use this initial condition to find a instead. Looks like y will be 5, so it's going to be 2 times 5 plus 1, that's 11, equals a. Well, a lot of times your initial condition will be 0, and that's great because you're going to get something e to the 0, and e to the 0 is 1. So this looks like my a is 11 here. So now we're ready to go. 2y plus 1 equals 11e to whatever this thing is. Last step, let's isolate. What do? We're going to subtract 1 and divide by 2, and we're going to call it a day. So this would be y equals 11 e to the 2x cubed over 3 minus 1, and we're going to divide all of that by 2, and that's the answer. So this is really the hardest it gets. Maybe not the hardest it gets, but definitely a difficult level where for these separate and integrate questions, where we separated both things, we took the integral, and we're careful that the integral of this did require an use of in our head. That's why this 1/2 is in the front. Instead of multiplying by 2 like the chain rule, we multiplied by the reciprocal of the derivative of the inside function, 1/2. Then we remember that before we want to go for the a step, it is one of the most fun steps to do in math. We still brought the 2 over so that we isolated ln. Then we did the a step. Whatever's in the absolute value of the ln, we wrote down on this side. Then we wrote a e to the function of x, which in this case was 2x cubed. Finally, just like normal, we plugged in our initial condition, found our a, and then found our function. So that's how you separate and integrate. And again, we are going to produce more videos on differential equation unit, but this video in and of itself, this process is the most important process of this playlist. So if you want more practice with this, I highly encourage you to watch our Girls Teach Calculus video, where one of my former students practices a lot of these separate and integrate questions. She practices questions that involve u sub, she practices questions that involve the ln of y case. So be on the lookout for that. I'll link that in the description below. We also created 11 differential equation free response questions, and this is such a big component of the differential equation free response questions, not as big as a multiple choice question because it's so long of a multiple choice question. So check out those videos if you want to practice. I talk about all the differential equation free response questions that you might see in an overview video. Then I go from difficulty number 1 through 10, running through differential equation free response question examples, where the key process in all of those questions is the separate and integrate process, this one right here, where sometimes it's non-ln of y, sometimes it's ln of y. So sometimes you're solving for that plus c, and the ln of y case, you're changing the plus c to an a, and you're solving for a. But whatever you choose to do, whether you continue watching our differential equation videos in this playlist, or watch the Girls Teach Calculus videos, or watch the Frick videos, we highly appreciate you watching our videos. Give us a like and subscribe if this were useful for you at all. And whenever I see you next, I hope to see you then. So thanks again for watching, and goodbye.